So good morning children. Today we are going to solve questions related to show that a function is 1, 1, show that a function is onto. For example, as you already see functions of different kind of x is equal to 2x plus 5. Let us suppose this is a function and they ask you to prove that this is an 1, 1 function or this is an onto function. Let's see the first thing, how to prove it is a 1, 1 function. So to prove it is a 1, 1 function, we have to take two characters, means f of x1. Let us see what is the image of x1. 2x1 plus 5. Now what is the image of x2? 2x2 plus 5. Now the basic problem is, okay, so we have image of x1 in the function and x2 in the function. So what does a 1, 1 function mean? 1, 1 function means it must have two different elements, x1 and x2 must have two different images, i1 and i2. Then only it is 1, 1 function. What happens here is, in our case, they two are different. Now we have to prove that it is 1, 1. So like in 10th standard, we used to prove root 2 is irrational, root 3 is irrational. So let's take the contradiction. That is, these both have same image. Let us suppose f of x1, this is f of x1 and this is f of x2. Let us suppose these two are same only. That is, f of x1 is equal to f of x2. Let us imagine this is the case. Then what happens here? X1 and x2 are mapping to the same thing. That is f of x1 or x2, whatever you write. So in this case it is a function, but it is not 1, 1 function. So if what happens when you take like this, let us see what is the value of f of x1 from here. 2x1 plus 5. So 2x1 plus 5. Similarly, what is the value of x2? That is 2x2 plus 5. So that is, let us suppose 2x2 plus 5. Now let's simplify this and let's see what we will get. This 5, when it goes the other side, it becomes, when it transposes to other side, it becomes negative 5. So gets cancelled. And if you send at the other side, 2x2 by 2 gets cancelled. So what you get ultimately is x1 is equal to x2. So what does that mean? If you equate these two, if you imagine these two are same, then these two also will be same. Then what happens? X1 is mapping to f of x1, only one category. So it is 1, 1 function. So this is the basic philosophy. So let us see the way of proving this. First, what we assume that f of x1 is equal to f of x2. Let us assume, and we prove that x1 is equal to x2. If you can do this, then the given function is 1, 1. So now basically the question arises. In this way, you must be thinking, whatever question you give, we will be able to prove. Take any example in the function. If you put f of x1 and f of x2, if you take the values and check, what happens? Automatically they both get cancelled and ultimately you will get x1 is equal to x2. So why is this process necessary? In this meaning, in this way you are going to get 1, 1, every function has 1, 1. You might be thinking like that, but there is a catch here. Let us take functions with the powers, even number powers, that is x square or x power 4 or something like that. f of x is equal to x square plus 5. Let's do the process once. So f of x1 is equal to f of x2. So the x1 becomes x1 square plus 5, x2 becomes x2 square plus 5. Now plus 5, if it goes the other, if it is transposed to the other side, so it becomes negative 5. So both gets cancelled. So x1 is equal to square root of x2 whole square. You might be thinking x1 is equal to x2, so it is 1, 1. But here, what is the output of this function? x1 may be equal to plus x2 or x1 may be equal to minus x2. So here in this case, what's happening? Even in general terms also, if you check, negative 2 and positive 2 will be having same x square plus 5, negative 2 square 4 plus 5 9, and positive 2 also 2 square plus 4, 2 square, that is 4 plus 5 9. So both will be mapping to the same function. So each element, one image, unique image जो system है, one function का जो basic thing that is missing here. So we can say that this is not 1, 1. So basically what we are saying, wherever there is a function with even power, the chances of 1, 1 is 0. But here also there is a catch. Sometimes f of x is equal to x square is 1, 1. When is this? This is when the domain is natural numbers or whole numbers, where there is no, or r plus, only positive real numbers if you take, there is no question of negative number at all. So here in this case, x1, when you get x1 square is equal to x2 square, automatically x1 is equal to square root over x2 square. So square and root gets cancelled. x1 is equal to x2 you get, but x1 is equal to minus x2 you won't get, because there is no minus x2 at all in the domain. So in such case it is 1 1 function. So this is what we have to be very carefully observing. So this is how to prove 1 1 function. Now let's move on to the onto function. Onto function, what happens?